Okay, so whatever we did for edit and delete, we have to do same thing. We have to do same thing for the saving it in the local storage. Okay, so let's try to do that in the local storage. So we have this results page, and same thing what we did here. We did it in the results page. So I'll copy some of the item so that it's wherever it is double work. So we have the edit part. I will copy the span of the edit. And what we are doing, we are trying to set the value to index. So which record I am trying to edit it. That's what I want to set the value. And then I will also set the input of the record which I want to edit it. Same thing which I will do here. Here I will create two variables. One is the constant set in, one is the index, which index I want to, since index is here, limit to some other thing, value and set value. So same thing which we'll do, but here the idea is we have to use the local storage rather than the state values. So I'll use the use state. Initially I will give you the value of the null, and later on I will update with the whatever record I want to edit it. So initially I gave null. So let's test out this one. In the app.js, I will point to topic 2 because we will be doing local storage now. Okay, let's try it now. Okay, so I set the value. Once user click the edit button, so let's create the span with edit. And when someone will try to click the edit button, I will set this value to the index of this record. So as soon as I click edit, I will say set value of index, whatever index I have. And I will try to see what is the value here. Now we are doing local storage part. So whenever someone try to add, it will also go into the local storage. So when we want to edit it, so after editing, we also have to update the local storage. That's another thing which we have to do. Let's try to run this one. So we have, since it is local storage, I can see already we have records in this. And let's go to the application. So there are two things here, local storage, station storage. If you use local storage, it will save here in local storage. If you save in station storage, it will be saved in the station storage. Local storage can be saved permanently till user clears the cache in his browser. But station storage is saved till the browser is open. When the browser is closed, then station storage will be gone. So in the local storage, we see topics. All topics are there. If I click edit, you will see I see the value 0 because I click the first one. I click the fourth one, value is 3. I click the fifth one, value is 4. So whatever I click, I get value here. Okay, so now we also have to set the record, which record I want to edit it. So I will also create another variable. Maybe I can say what I'm using here, input. I'm using input, so let's use input. So initially it will be empty, and as soon as someone click it, I will make this set input to record. So whatever record I am trying to edit it, it will be saved in this state variable. Let's double check what we are getting here. So as soon as click the first one, you see value is 1, test, input is test. Here value is 3, input is test 4. So we are trying to set the index and the record which we want to edit it. Now what we'll do? Now we will create a text box which will be visible only when the value is not null. If value is null, that means user has not clicked the edit button. So we have to create an edit box. So let's copy it from here, this edit box. So this will be only be visible if someone has clicked the edit one. Okay, like now I'll just create a number function. So as soon as someone click the edit one, for that I want to show this edit box. So how to show that edit box? So I will put a condition if this index is equal to this value, because whenever someone clicks this, we set this value to the index. So this will be value. If both are same, that means we have to show the edit box. And edit box will have pre-filled value of input which user has updated as soon as he clicked the edit button. And also the index is updated. Value is updated with the index which user has clicked the edit button. So if I go now, I click the last one, I see here. If I click fourth one, I see here. So wherever I click, I see the text is updated here. Now someone clicks submit button, I have to update the value. I have to update the value of this topics, right, in that one. So I have to update the row, and that update should be updated in this topics one. So here what we are doing, here we are passing the set topics also, because as soon as someone will update it, we need to call the set topics, and we will update the state also, and we have to update the local storage also, because tomorrow user will refresh the page, he should be able to see the results. So I will also pass set topics here in the results page, and from the previous page, that is in the topic 2, I have to pass the set topics also. So set topics is passed from here results page, from the topic page, and then it goes to results page, and in the results page we get the set topics. So as soon as someone click the edit one, we have to update the record as we are updating here, and we have to update the local storage also. So what we have to do, let's create the function and they'll update. It is same what we did last time. You can walk through the last video also if you want to go through in more detail. So I'll call the set topics. Set topics has an arrow function, and it will get the previous value. So I will create one temp variable which will be copy of the previous value, and then I will say temp of the current index which I want to update it is equal to input value which user has updated it. So then I will return temp. Still I am not using the local storage. First I want to see if it is updated properly. So let me console this temp also and call this handle update on the click of this submit button. So let's try again now. So now I will edit this one and update it with Mango. As soon as I click submit, you will see temp has Mango here and topics is also updated with the Mango. And when I refresh the page, refresh is not updating because we have not set the local storage. We have just did this. It's still on the state variable. So Mango is updated in this topics list, but we have to update the local storage also. So here also we have to update the local storage. So we'll go to add topics and see what we are doing in the local storage. We'll copy this part and here I will paste it. So I am setting, instead of array I will put temp. So whatever we are getting in the temp is updated in the local storage. And let's refresh the page. Now if I put Mango is updated here. And in the application also you will see Mango is updated here. If I refresh, I am getting a Mango. Let's change it to Apple. Let's change this to watermelon. But as soon as I update it, I want this text box to go away. So what I will do, I will make this value to null. So as soon as I update the topic, I will also set here set value of null. Because value is null, then we will not be showing this part. So let me submit it. This is on. And then here grapes, here banana, here we can say oranges. We get list all, and if I refresh it, I am getting the updated value here. Is that clear? Any questions on the edit part? Any question on edit? Okay. So similarly, what we did in the delete part, what we did here in the delete, you have to do the delete yourself and show me tomorrow. Show me tomorrow the thing is. So how will you share with me? You can either comment in the website or better is you can create a project in the GitLab. Create the project in the GitLab and share me the public URL for the GitLab. Because whenever I ask you also to complete this project which I gave you last time, I want each project to be in your GitLab, and whatever pages you have done, you have to share with me your GitLab URL so that I can check whether your add part is correct or not, whether your review system is correct or not, whether this medical system is correct or not. So you have to share with me, the what you called as the GitLab URL so that I can review it. Okay, because we will be doing this the things will become very complex soon, and I want to review it in the GitLab because otherwise I will not know what mistakes they have done it or what changes need to be done. Okay, so this one was one thing, right? Let's go. Let me put it in the here, and then let me put here so that you can see the is something I can copy, quick edit, view cache. If I select this, there's no way I can create a duplicate. Okay, let's so let me create a new one, and I will, okay, I will not create new one for this one because this is simple change. You can use this one and try to add the local storage part. Okay, so I'll not do that for now. I may do later, but not now. Okay, so that's all for the edit part and today's React part. Let's move to some other stuff now. So what we did, React.js, edit form using local storage. We did this one. Okay. Now we will move to some of the data structures and we'll see how to implement the things on the in the data structure. So one of the data structure which we have to learn is the single linked list. There is double linked list also, which we will not see in the main course. You know, I will put the main course, and there will be side course. In the side course, we will see some other stuff like double linked list, which are not very important, so I put it in the side course. The main course will put the important stuff. Then we have stacks and queues. Then, so we will be doing different data structure. I will put the names here. Let me see what is the next one. Yeah, so next one is binary search tree. And then we'll go with the, in this only we will go the tree traversal. Okay. Then next we will see is binary heaps. And then we will see hash tables. And next we will see graphs. Okay, let's move this hash table. Though hash tables are important, but I will move it in the side code because in JavaScript, whenever we create object, it is a hash table only. But there is some additional, you know, very different kind of logic which we will see in this hash table. So which is not very important, but whatever in the JavaScript we use, it's a hash only. So we'll see graphs and graph traversal. And also we'll see one of the important concept of the graph. It's called I don't know how to pronounce it. Algorithm. Dijkstra, we can say Dijkstra as a this should be silent. Dijkstra algorithm. So these are the 5 tables, 5 concepts which we'll see in data structures, and we'll see how to build a structure for that. So we'll start a single list today, and will not complete today, but we will try to do this, start this today. Any questions before I start? Okay, so let's continue. Let's start. So we are going to do linked list. In the linked list, you know, the concept is like there is a head. This head is there. So we have seen the arrays. Arrays is like indexed from 0 to n number, and we can put anything here. And to access any element, we know the reference of each one. We can directly access that element whenever we want to. So for example, if I want to get this element, I can say array of 0, 1, 2. If I say array of this 2, I will get the value 3. So immediately I am putting 2, I am getting the value of 3. But in the linked list, we don't have the exact location of 3. We have to travel from start to end. So from head, I will go to first element. So here I create node, especially node. Node has the value of 1 and the address of the next variable. So head has a address of this node, and from here, let's say consider this is our top one head, first element of the head. So it has a value and it has the address of the next element. So next element is 2. So this one has a value of 2 and it also has the next element where it will go, where it will find the next element, then it is 3. So if I want to access 3 in array, I can directly write array of 2. I can access the 3. But with the linked list, I have to first start with the head, travel 1, then 2, then 3, and then I will know where exactly S3 is. So I cannot directly go to 3. I have to start with the head and go to the 3. So that's how the linked list works. And this chain goes on until it encounters the null. So the last element has no new address. So this node does not have the next pointer. So each one has next pointer where it wants to go, but the last element does not have the next pointer. So this is what we will be doing the linked list in our chapter, which we're going to do it. So for each one, this node, we have to create the object for this each node. And this node has two things. One is the value, which is 1 right now for this one, and one is the next pointer where it wants to go. So each one has two things, value and the next address where it wants to go. It has a value of 1, next is this pointer, this one. And this one has value of 2 and next is this one. This one has value of 3 and next is null. Whenever the next is null, that means it is the end of the linked list and we cannot go further. It is done. So we are done with all the elements. So before we really jump into the linked list, we have to create the object of this each node. So this is the node. We have to create the object of node. Okay, so let's try to create the object of node. So let me create a folder. So in the data structure, I will create a new folder, linked list. It will be single linked list. And I'll create a new file, 01 linked list.js. Okay, so here, before even I jump and do the linked list part, we have to do this node part. So to create the node part, I will create object for that node part. I can create class, and I can use this class also, or I can also, if I say class node, then I can call node equal to new node. Like this, I can call this class. So I create this object from this class. I can also use function and I say node. So if I write node as a function also, then also I can call constant node equal to new node. So there is only the syntax difference. The ultimate result is same. If I don't put new, then it is a simple function, and whatever you will return, it will be saved in this node. But if I add this new here, then it will become the object, and we have a normal object of this function. So anything if I want to access it, so for example, this node has a value. So anything which I want to create a variable, if I use this constant value here in this function, then I cannot access this value, this wall outside this node object. So I have to every time use this dot wall equal to whatever value I want to give. So once I use this, I can access this variable outside here in my node object. So here I can say node is node dot. When I say dot wall, so it is nothing but this dot wall which I have created inside. So whenever I want to create anything which is publicly available, I will use this keyword inside this function. And this function will become the object, and I can create a new object based on this function using this statement, this syntax. So don't worry about too much on this one. So only thing I just want to show you that I created one function which will be called as an object, and here I will put two things. One will be this dot value and one will be this dot next. This dot next initially I will put always as a null, and wall, this dot wall will be something which user will pass. So if user will pass whatever, I will assign it to this dot wall. So let's say I created this node with the value of 1, and then I do console.log node is node. Let's check this one what we are getting it. I will say node. So once I run it, it's saying node is node with a value of 1 and the next is null. So we created something what I showed in the diagram. Let me create the diagram again. So this is my head in the linked list, and it will point to first node that has the value of 1. Initially we don't have anything behind this one, so initially it is null, pointing to null. Same thing I created here. This node is there with a value of 1, which is this one, and the next is pointing to null. Next is null. So I created this one. Let's try to update the next value of this one. So I'll say node.next is equal to new node of 2. So what I did, I pointed next to another node which has a value of 2. So I will run it. Now you will see node is their value of 1, and next is pointing to value of 2, and 2 is pointing to null. So what we did the change. We did the change of, can I, okay, let me delete this one. So what we did now, we added a new node with a value of 2, and it is now pointing to null. See, I created this new node, which is first there was 1, and then there's a 2, which is created here. Now I can add one more. Node.next is equal to new node, and I point to 3. Now if I run this one, you will see first node is value of 1, pointing to second node, which has the value of 2, and this 2 is pointing to the value of 3, and 3 is pointing to null. Like this I can go on to n number of values, and one will be pointing to another, second will be pointing to third will be pointing to 4. But we are creating this manually. It's not automatically created. So the purpose of linked list is we will write some code where this node chain is created automatically in our code. So right now we have only concentrate on the node part, and I created this third node also, and this is pointing to null now.
I have one question here.
Yeah. What pardon? What do you
How are
say?
we connecting head to node 1? Okay.
Can you speak loudly? Last time also you were speaking so slow. I'm not able to get it.
How are we connecting to node 1 from head?
So this one is said as head. It is called as head. So we are starting from the one. So we are saying that head is started from the one. So this object which we are seeing, is actually this will be assigned to variable called as head. We can name it anything, but when we will build the linked list, still we have not built the linked list. So when we will build the linked list function, then we will create a variable head which will point to 1. Okay. So we have still not created the linked list. So this is the virtual kind of thing. So consider this head is pointing to this one. So right now you don't see head because I did not create any variable head. But consider this head is pointing to 1 and 1 is pointing to 2 and 2 is pointing to null. Or here head is pointing to this node which has a value 1 which is pointing to different nodes. So right now it is in the air. We have not assigned to variable head. We will assign this to variable head in linked list function. Right now we have created manually, so we consider it as a virtual thing, not the real. So we consider this head is pointing to this first one, and the first one is pointing to second one, second is pointing to three. Is that clear? Any question on this one? So right now you only think that we have created a chain, but it is not assigned to any head kind of thing, which we will do in the linked list function. So I have not created the linked list. In the linked list function, I will create one head as a variable, and this whole chain which I built it here will be assigned to head. So the head will be pointing to wall 1, 2, 3, and then so on. So this is the node which we created. I just don't want to go to linked list today. Just wanted to show you that we created this node. Let's consider if I want to uh, create a binary tree, which we have not done yet, and I don't want to do more on it, but I just want to show something on it. So binary tree is like this. There's a parent, and then it has two children, left and right, and then this one has also two children, this left and right, and this one also has two children. So when we will build a node for this tree, here we created a node for linked list. Let's say if I want to create a node for binary tree, so I will create like this. I will create the node like this. I will say value because each one will have value, so value will be there. But next will not be there in the binary tree. Next will be left and right only in this case. So I will say left and right. Because binary tree has a node and it has left side and the right side. So we have to create a node in a different way for the binary tree. So for binary tree. Okay, so we have to create a, and if it is a normal tree, then we have to write different node, which we will see soon when we reach to that point. So just I wanted to tell you that this node part changes based on the data structure which you want to use it. So generally we have node in all the data structure because wherever we want to save, we have to save in this node part. And then there will be another function which will be the main part of the data structure, where we will use this node and we will manipulate by traversing, adding, removing, and doing many stuff kind of thing. So that's what I wanted to tell you. I will go through each data structure and we will see the node in each case. Now today we have seen the node in the linked list. Now we will start the linked list function today, but will not go in detail, but at least we'll see little bit of it today. Other things we'll see tomorrow. I will go the data structures very fast in couple of days as soon as you pick up. Initially I am going little slow, but in few days I will be getting it very fast. In few days we'll do a lot of things in each data structure. So let's create another function called a single linked list, and then I will create a variable list equal to new single linked list. So whenever you want to create object, you have to use this new keyword. Then this function will not behave as a normal function. This function behave as an object. And whatever you will write in this function using this keyword, then all this will be the part of that object. So here I created linked list function, and then I will do console.log of list is list. Okay, I wanted to say this node part, so I will do Control Z and paste this one. Okay, let's keep this node part. I'll comment it for now. So now if I run this function, you will see the list is single linked list, and all the manipulation which we want to do in the linked list, we'll do it here. So there will be first head. So any linked list should have this head. Many people also say that we should add tail also, but for single linked list, we will not add the tail. We will only add the head. So since we have to add the head, I will create a variable called as this.head, and initially I will point it to null because nothing is there. Head is pointing to nothing, so that means head is pointing to null. Nothing is there, so it is null. So now in this linked list, we have to do lot of things in this one. Today we will define what things which we will do in this linked list function. So first thing, whenever we do each one, I want you to answer it how we are doing that thing. Right now, I will just put the name, what we are trying to do. So first thing which I want is, I want the size of this linked list. Size means, let's say if I have 3 elements, like I have 1, then it is pointing to 2, then it is pointing to 3, then this is pointing to null again. So this is my chain of linked list. So if I want size will be 1, 2, and 3 because 3 boxes are there. So I want the size of 3. So if I call this function, I should be able to see the size of my linked list. If there are 100 items, I should see 100 items. So this is the function which we have to write in our case. Another one is as soon as something is added, like 3 is there, I want to add 4 number. That is called the push method or insert, we can say, or we can say push method. Push means we are adding at the end of the linked list. I will write down some explanation. Total elements of linked list. And push means I have to, like in array we have the push. So add the item at the end of the linked list. How to add the item at the end of the linked list. Next will be, so there will be many functions I will be writing. Let's do another function. Get the last item of the linked list. So if I 1, 2, 3, I want to get the three number, this node, I will call this function get the last item 1. So here I will name it as get last. So we'll go through each function and see how to write each function, and you will be guiding me how to go through it. I will just help you, and you have to tell me how to go through it. Let's say if I want to go through each one, 1, 2, 3, so it is called traverse. Go through each item. So this is called traverse. So I have to traverse also. All these functions will not be there for all the data structure, but for linked list we have this much. These are the important things which we get in interview also, and for your practice also we have to use this one. Let's say we have to reset the linked list as previous state, that is nothing is there in the linked list. We can call the clear function, which will clear the linked list and all elements will be gone. So this is another function which we will do. Next is take the item out from the end of the list. So like in array, we have the pop method where we take the elements from the end of the array. Similarly, we will create a function called as pop, which will take the item from the end of the linked list. Okay, next will be this dot get. Now get will be, I will pass the index in get, and at particular index I want that element, so that element I have to fetch. So get node at or get element at particular index. So let's say index start from 0. I have 0 for this one, 1 for this, 2 for this. If I pass 2 number, I should get this element. If I pass 1 number as index, I should get this element. So index we have to pass and get that element for us. Now if I want to get the first element, I will call this function. First element will be this one. So I will write out this. Many functions are just for learning purpose. So to see how much, it's a practical good exercise to do all these things. Next will be the search one. And here I will pass the value, and we will go through whole chain and see which one has this value matching. So for example, if I pass 2 number and 2 number is here, so I should return this element. Or I can say it is true, it is present, or I can give that element, whatever I want. I can give that element, or I can give the true or false. Let's say if I want to remove, we have seen this pop will remove from the end of the list. Let's say if I want to remove from any place, so I will pass index here, and I will remove at that particular index. So for example, if I pass 1, I should delete this, and I should join this 1 to third number. So I have to remove this, and I have to join 1 to 3. So this is called the remove. Next will be, like in array, we add the we remove from the beginning. That is called shift. So I will use the shift method. Shift is adding or removing from the beginning. What is it? Shift is removing, unshift is adding. Yeah, shift is removing, unshift is adding from the beginning. So we can add from the beginning using the unshift method. So like in array, we have unshift where we add from the beginning, and in the shift for the array, we remove from the beginning. So this is used in array, but same thing, implementation, we will do in this linked list. also one last thing which we'll do, two things more we will do. This dot set. Set means I will pass, I will update it. That means I will pass the index, I will pass the new value. So let's say if I pass index of 1 and value of 5, so it will change, remove this 2 and make it 5. So it will update this node. That is called set. And the most typical is reverse part. So we will do reverse one. This will reverse the whole list. So for example, 3 will become first number, 2 will remain 2, 1 will become the last number. So we will reverse the. So these are the functions which we'll go through in the next class. And then once this is done, we'll go to next data structure, that is the stacks and queues. And then we'll go through all in few days. We'll go take this one. This is the important thing which we'll take along with React also. We'll do React part also and this one. Any questions? Okay. Nice. Let me